Hello and welcome to What's Bubbling is ZIM Bubbling. I'm inventor Dan Zen, and in this bubbling it's the third part to a three-part series that is looking at an exercise within the ZIM Learn section and in specifically module 2 of the lessons there. So have a look at the other two bubblings to introduce all of that. And basically what we're doing is we're trying to get two blobs to match. So we've got a model blob that is randomly made. And then we've got a blob here. Let's just take a look. We've got a blob on top that we can move around. So we can move this one, but we can't move the other one. And we're trying to make this blob look the same as the other blob. So here I'm just at the sort of the end of that. Are you ready? Oh, there we go. It matched. Okay, and so when it matched, we know that it matches. So in the other bubblings, we took a look at how to make a random blob. So that's that blob in behind there. And now we want to see how do we test to find out if all of this stuff matches. So I'm going to show the answer here. And you can see that it's got control points. We can't control those control points. They were made randomly, but they're there. And as we move that, you can see that if I let go, it's going to check that we're close enough. We're within 15 pixels. Whereas if we aren't within 15 pixels, it will know. So we have to compare these circles to find out if the circles are in the same location. And we have to compare the rectangles here to see if the rectangles are in the right position. Now you may notice something here that this rectangle always remains horizontal, or whatever you want to call it, and yet these ones are not. These ones are perpendicular to the sticks. Now the reason for that is, and it's quite important, the reason is when we made the random blobs, we actually took what was called the set. So that's the container of the set of these things. So the circle, the two rectangles, all in a container, we'll call it set. We rotated the set. We positioned them in random places, but we also rotated them. So there's a big difference. In this set right here that we're moving around, the position is great. That will be the same position, no problem. But as we do this, we're not actually rotating the set. All we're doing is moving a rectangle within the set, and the set itself isn't rotating. And what that means is, unfortunately, we've got two different coordinate systems. If we're wanting to check to see if these rectangles match the other rectangles there, we have to convert the position of this rectangle from within a rotated coordinate system to the location of this rectangle or this set, which is not rotated. So this set is not rotated, even though it looks like it's rotating. It's not rotating, just the rectangles are moving. Okay, so that means we need to use local to local. And that's going to be one issue. If we're wanting to find out if this rectangle matches that, we have to translate or convert the local position of this rectangle within the set that has been rotated to the coordinate system of the second set, which has not been rotated, okay, to find out if the positions of those rectangles match. So that's one thing. The other thing is, imagine that we're moving, here I'll just do a refresh on this, Control R. Imagine that we're moving these things around to try and match that. And if we take a look, there's a circle. So imagine we've moved that to the right place, which we just did. Okay, now great, that circle's in the right place. What about this circle? Now, if we take this circle, we want to then match it to that position. Now, it doesn't actually matter. We could match it to this one and move this one and match it to that one. Sometimes they're going to be crossing over to actually get the right shape. So we've moved it to there. Okay, now, but the idea is if we've matched it there and we say, yay, it matches. Now we go to the next one. We cannot match this one to the same one. We have to match this next one to any of the remaining three. Okay, otherwise we could just say, yay, that matches. Yay, that matches. Yay, that matches. And obviously that shape doesn't match the overall shape. Okay, so that's another tricky part, is that each time what we're going to do is we're going to take the circles or the points of this outer one. We're going to take this one to start. We're going to say, does it match any of the ones? And if it doesn't match, then we just say no match right away. But if this one matches, then we have to go to this next outer one. This is our outer loop. We go to the next one and say, does this match any of the remaining points of the inner one? Okay, we can't include that one, which means once this one matches, we have to take that point right there, the one in behind, we have to take that out and say, okay, great, that one's already been used. Now we have to match the other ones. So the way we're going to do that is we're going to take the points of the background one there, of the what I call the inner one, I guess. This is the outer one because it's just on top. We're going to take the points of this blob, the model blob, and copy them into a different array. So each of these points is stored in an array called points. And we're going to take the model's points and copy it so that when we remove the point from the array, we don't mess up the actual blob. Okay, got that? Also, we want to keep an original version of it because each time we're testing, we've got to remake that copy. Otherwise, we might be testing on an old copy, you know, that already had some removed, but now I've moved one that did fit before to somewhere else, and now it doesn't fit anymore. You know what I mean? We need to remake. Every time we go to check this, we need to remake that copy. And we're going to call that copy compare. Okay, and compare will have all of the remaining points that we can compare to. All right, so let's go into the code and take a look. Code. Reduce that, I guess. Get into code here. And we, in the previous bubblings, we got up to a point of how to make a random blob. And we also introduced where the lessons were and all that kind of stuff. So just quickly, they're in the ZIM site in lessons, and then you go down, you go to the module 2 and look at the second workshop in module 2, and you'll find an exercise in there. So that's the exercises.html page we're in here. All right, one of the first things we do is, where do we do the testing? Well, we can do the testing whenever the blob changes. So I've put in a message there saying change, and let's take a look here. So if 12, that whenever I move the blob there, well, let's just do a refresh on this because it changed so much last time. So I move the blob and let go, change, and it says no match. Okay, if I move this stick, change, no match. If I click on the blob, nothing. So in the exercise itself, I think I started off with a press up, or was it a, yeah, press up, like so. Okay, so here there's a difference. If I press up on the blob, press up, no match. Look, I'm not even changing anything. I'm just pressing on the blob and I'm getting, and it's doing the testing. So that's really a waste of resources. It does do the testing here when I press up on that stuff because that's part of the blob, but I don't really want to use a press up. So it's probably better to use a change, like so. Okay. So here's us making a copy of the points property of the model. Shall we just go in and see what the points property is? Let's go back to here and we'll go into the documentation. Put that up a bit. ZIM docs, blob, like so. And we scroll down in the blob. There's the parameters. Now there is a points parameter, but that's different. The points parameter takes in X and Y coordinates for all of these things, the control point, the circle in the control point, the rect in the control point, etc. So there's a message here. Note, this format is different than the points property. Now we've already made the blobs and we're comparing the points property. So we want to go down to the properties. And here's the points property. An array with access to the control point data with the following format. Note this format is different than the points parameter. Okay, they're related, but they're different. So this is one point right here. Here's another point. So in other words, it's an array of all of the points in our blob. Each point is an array itself. We'll have the set as the first thing. The set is the container that holds the rectangles and the circles. Then we have a reference to the rectangle, one of the rectangles, a reference to the other rectangle, and a reference to the circle. Okay, now when we move things, we're really moving the whole set. But when we move those rectangles, we're moving the x and y of the rectangles there normally. So let's go in other words, if we want to reference the set, then we're going to take the point at 0. If we're going to reference the rectangle, we'll take the point, rectangle 1, we'll take the point at 1, and take the point at 2 to reference the second rectangle. So we're making a copy. Now just beware that when we copy that array, we can't just say compare is equal to that point. That just makes a reference to it. And if we started taking elements out of compare, it would actually take elements out of our array. So we don't want to do that because each time we need to remake the array back from the original. Okay, so we're going to make a copy of it using ZIM copy, and that even if there's things inside that, it will make a copy of those as well. So the copy is it goes deeper inside. Okay, it's recursive. So we will copy the model points and put that into compare. Okay, now we're going to do a ZIM loop through the outer points. So this is through the points of the blobs. And each time we loop through the points array, we get given the point. So in other words, we're looping through, let's just look at this again, we're looping through this outer array with ZIM loop, and that's called the points. And each time we're given, as a first parameter there, we're given the element of the array at that index. And so we're given an array of set rect1, rect2. Got that? That's what that is. Okay, so that's the outer loop. We've also got an inner loop, and the inner loop is we're looping through all of the points that we're wanting to compare. So the first point we're going to check, is it matching any of the points in compare? Okay, and so that's us looping through each one of those, and each time we get a test point. We're also asking for the index, because if it does match, if these 2 points match in all their ways, if the locations of them and their rectangles all match, then we want to remove this point from compare. Remember? Okay, because it's matched. So then when we go to the next outer one, we want to just check the remaining 3. So we're also collecting an index. And this is how ZIM loop works. If you loop through an array, the first thing is the element of the array at the index, and the next thing that you get passed to the function is the index. Alrighty, so what about this result thing here? So imagine that it does match. Okay, let's just go down and see what it matches. And we talked about removing the matching point from the compare array. So let's go down and find out that. That's right here. So there we say take out the matching element. Now, how this works is basically, just give an overview, is if none of these match, then we return. When we return in a ZIM loop, so this is this ZIM loop right here, if when we go to compare our point to the other point, if it doesn't match its location, or if it doesn't match its rectangles, we'll get in to see how it does that, then return exits this function right here. Okay, a simple return with a ZIM loop exits the function, and it goes to the next thing in the loop. So in other words, a simple return in a ZIM loop is like a continue in a for loop. Okay, so ZIM loop doesn't have a continue. A continue is only allowed to be used in for loops, or maybe while loops, you know, like proper JavaScript loops. So we're running a function each time. So if we want to leave this function and go to the next one, then we just hit a single return. So if none of them match, we get a single return. So if it ends up going through all of that and none of them match, then checkpoint will be false, or there won't be any checkpoint. Because take a look, if something does match, so if it gets through all of these things, these are all if it doesn't match, but if it does match, then we're going to splice out that point and we will return true. So remember, we're still in a ZIM loop. A return of true, or a return of any value other than just plain return with no value. A return of any value is different than just a plain return. Okay, a plain return exits the function, goes to the next one in the loop. But if we return a value, whether that's true or false or 7 or hello or anything, if we return a value, it exits the loop. So it exits the loop, and the loop will take that value that got returned and indeed return it itself. So it will be put in there. So in other words, if it matches, we'll return true. If it matches, we don't have to loop anymore, so it exits and puts true into there because we returned true. So checkpoint is true. So in other words, one of the points has matched the point that we're checking for. So if there's not a checkpoint, so if none of those points did match, if there's not a checkpoint, we return fail. All right, so this is the outer loop right here. We're in the outer loop, and when we return fail, it's not just a simple return. It's not that. Okay, that would just go to the next one. But we've actually returned a value of fail. What that means is it exits the outer loop and puts fail into result. Okay, after the outer loop, this is the outer loop, after the outer loop, if the result is fail, then there's no match. So as soon as anything breaks, if it can't find a match, then it's going to return fail. Okay, and we come to here and there's no match. However, if it never returns fail, that means everything matches. Okay, there's no return in that loop, therefore the result is not fail, and therefore we match. And at that point we exit to Dan's End, or do whatever we want to do. Pop up a pane that says you win, or animate the blob, spin it around and make it go boing, boing, boing. Who knows? Okay, so that's sort of the outer structure. And things to remember there is that if within a ZIM loop, if you just return, it just goes to the next one in the loop. It's like a continue. But if you return a value, then it's like a break. Okay, that would be like a break in a for loop. It ends that loop. Not only is it a break, but it takes that value that's returned and it returns it itself. So that goes a bit beyond break. It's kind of cool. Now we have the ability to find out what is happening in a loop, and that answer can come back into here. All right, so what do we have to look at next? Where did we get to? How about, we're now finding out, how do we know if it's failed or not? Like, how do we know if there is a match of location of the point and a match of the location of the rectangles? Okay, so let's take a look. How about, we'll leave the rectangles just for a second, and we'll just look at this very first test. This is finding out if the points match their x and y positions. So we're using this function called within, and we're asking if the point's x is not within the model's x, like within 15 pixels from it, and we'll see why. That's within. Within. Oopsies. Okay, so if the x points match and the y points match, well, actually this is saying if they're not within. So if they don't match, or the y points don't match, basically then we're returning to check the next one. Okay, so that's how it is. It's like a gate. If the x doesn't match, the y doesn't match, the rectangle doesn't match, if any one of those doesn't match, then we go and check the next one. Okay, so let's, should we look, we've got to figure out how do we know that these are the x and y points, or the x points of our blobs. There's that to look at. There's also what's going on within. Let's take a look at this part. Point at 0. So that's this outer loop. When we loop through the points of the blob that we're moving, we get a point. Point at 0 is the set. That's the whole thing, is the position of the whole thing, that whole thing with its registration point right at that circle. Okay, so is the x position equal to the test point's set's x position? So that's from the inner loop. When we're doing the compare, there's our test point. If we ask for test point at 0, that is the location of the set, or that's the set, the container, and the x position, we're comparing those two. No problem. Or if the y positions, same deal. Okay? Now, what about the within? The within is a function down here. here that just takes two values and finds out if they're within a difference. Okay, so if there's no difference passed in, we didn't pass in a difference, it'll take a default of 15. I tried 10 and it was hard, but with 15 it was easier. So if the absolute value of the difference between those two is less than the difference, then we're good. Just beware there, you need to take the absolute value just in case that's a negative number. Okay. So for instance, the difference might be -2. That means it's only 2 pixels away, but it's a -2, and that's going to be less than 15. So it would look like, if it's even negative more, like -25 is, yeah, that's right. -25, is the difference. That's less than 15 because it's negative, and yet it's too far away from each other. So that's why you do the absolute value. Okay, so it returns true if it's within that amount, and it returns false if it's not. So if you look up here, if it's not within 15 pixels, then we're going to go look at the next one. Okay? So now we arrive at the question of how do we handle the rectangles. So we have the, where is it? The compare. So we're wanting to check the rectangles that are inside of compare, and we're doing a loop, and we're getting a test point each time. So here's the test point. So what we have to do, though, is those rectangles inside of the test point are possibly rotated, randomly rotated out of 360, so most likely rotated. Okay, which means we need to convert those x positions of the rectangles inside of that rotated container to a point, an xy point within the thing we're comparing, which is the blob container for the set that we're moving. That's a lot of stuff here, obviously. So here is the x and y point of the rectangle 1, okay, that we're testing of the model. Here is the x and y point of rectangle 2. Okay, so the rectangle 1 is sitting inside of the container, of its container, all right, which is the set. So if we take a look here, rectangle 1, and we're doing rectangle 1, x and y, this rectangle is sitting inside of that set container, okay, which is the test point at 0. Test point is 0. Now, a lot of people, when they come to local or local to global, etc., is they get mixed up. They think, oh, I'm checking the rectangles x and y. Therefore, the local position would be the rectangle. So rectangle 1 dot local to local. That is not the case. All right, and that gets very confusing. And I used to always get confused with this too. The x and y positions are within its container, and the container is the whole set. So the coordinate space that we're looking at here is the container of the rectangle. Okay, so when we're going from the local position from within the container of the rectangles, so that position, the point that we're looking for is the x and y, and we're translating that over to the container that holds the set of our blob. So we're saying the point that we're looking at, that we're comparing, this is the coordinate space of that point. Okay, so that gets us a converted point of the rectangle within our set here. So when we come down here, we're saying, is the rectangle 1, so that now this is the point within here, within this thing right there, okay? That's the rectangle 1's x. Is it within 15 pixels from the converted location of the rectangle of the model? Okay, so we've taken the model and converted it into the same coordinate space. And now we can compare apples to apples, those x positions. Same with the y, and same with the rectangle 2. So my apologies if that sounds confusing. Local to local is one of the hardest things in interactive media. right there is converting coordinate spaces. And you may have heard of that in gaming. You've got matrices, and those are used to coordinate rotated nested things and stuff like that. So it's the same kind of deal. We use local to global, global to local, and local to local. Fortunately for you, ZIM has taken away a lot of those difficulties. Like if we're dragging things within nested, rotated containers, ZIM handles all of that stuff for you. Whereas before, if you just use CreateJS, it's not handled for you. You've got to then apply global to local and that kind of stuff, local to global. It's a bit like Inception. It's like nested within nested, and you're going, oh my God, ah. Okay, so great. Have you got that? There's a test. So this was all extra. It was just, a bit beyond. But I've always wanted to do this. I've always wanted to be able to compare to find out if two shapes were the same. And here we've done it. Isn't that amazing? I don't know if I want to do that one. do an easier one. So I don't know if that one's easier as well. How about this one? Anyway, so that's what that looks like. We'd have to then go and match each of these things on it. Well, I guess to this way, and dim that down a bit. Dare we try? These things go probably that way. What about this one moves to say here, and what does it do? Spin around? I don't know. Depends on maybe if this one needs to. Ooh. Yeah! We match shapes. Isn't that amazing? So there it is. There's shapes matching. I love it. Matching. All right. This has been Inventor Dan Zen here at a What's Bubbling at ZIM and beyond. Oh, holy moly skins. Hopefully that wasn't too twisty for you, but those are some of the nuances. That would be some of the most complex things you'll probably come across in interactive media. Are you proud of yourselves? Ooh, neato. Okay, have a great day. Ciao.